We are live. What's up, guys? This is Dem Keys, and today we are going to carry on learning about neural networks. Um, I think I'm getting a bit better at streaming more regularly, and I'm getting a bit better at the very least, doing the mute streams if I'm not able to do the talking streams. Fortunately, today I got a chance to do the talking stream. I think in my previous stream, I had said that I was going to be doing I can't remember exactly. Hold on, let me just check whether the last stream was a talking stream or a mute stream. So the last stream was a mute stream, and the stream before that was a talking stream. I do remember that I had said that I wanted to do a mute stream immediately after one of my previous streams, and then I ended up not doing it because I got busy, I think. I'm not sure. I don't remember. Either way, I'm trying. I'm trying to, get better at it. And I'm also trying to get that the AI voice tech going. There's a bit of research that I have to do. Not research directly into the AI voice stuff, but like there's a bunch of other research um, that I'm busy with, because of which I haven't been able to give this thing as much time as I would like to. Now, the ideal setup that I can think of in terms of that AI voice thing is, so I'd mentioned before that there will be two input modes. So the program can take two types of inputs, but there's only ever one type of output. So the one type of output is the AI voice audio along with text appearing on the screen. Both of these things are absolutely necessary. I can't, I don't want to go with either one. It has to be both of them because I want closed captioning on my streams, but I also want to do the AI voice thing specifically for my mute streams. Actually, you know what? No, actually, hold up. So I want to introduce closed captioning even during my talking streams. So I might need to add a switch to be able to turn off AI voice whenever I need to, but always keep closed captioning. This literally just occurred to me. I just remembered that yeah, I wanted to add closed captioning even to my talking streams. Yeah, I'm gonna need to keep that in mind. Okay, going back to that, the input thing, there can be two types of inputs. One is going to be through voice, so vocal input, audio input, and the other is going to be text input, so I'm going to be typing it out. Uh, if we are talking about text input, then the I want the input to be accepted from a different machine. So I'll type in the input into a different machine, so that I have a different keyboard that I'm typing through, and then I can send that data over from that machine over to this machine, and then process the data, run it through the models, and get the AI voice. So the actual, I mean, does that make sense to say the actual program? That they're both programs. The program that's doing all the heavy lifting, uh, all the ML work, all of the models, the program that's running all of the models, that's going to be on this machine from which I'm streaming right now. But for input, I want to have the option to do the input from a different machine. Uh, I need to see if I want to also do audio input from a different machine, as in from that same other machine from which I plan on doing the text input, because I don't know if that's going to introduce unnecessary latency. Because with text, it's not going to introduce latency. That's a sure thing. The text is not going to be big enough that it would need to be split into multiple messages. But audio, depending on how big I decide to make the chunks of audio that get passed into the model, depending on that, I might need to worry about, whether it should be captured from a different machine or be captured on the same machine. I also need to find out if I'm able to use the same mic in two different programs. Give me a sec. Because, like, for example, oh, you know what? No, this is actually a great example. My mic is currently being used by my VTuber program, my VTuber app, but it's also being used by OBS. So I think, yeah, I should be able to. You know what? Okay, okay. Then we can just record everything uh, through the same program, like, within the same program, just so I'm not introducing any network latency. And it's just going to be that one thing. Just the text input is going to be coming in from a different machine. Um, yeah, yeah, yeah. Though, I mean, yeah, yeah. It'll be better if the text input comes from a different machine. It's not going to be. It's not going to be that. Uh, how do I say this? It's not going to be that late, laggy. Yeah, it's not going to be that laggy either. Because like I mentioned, it's text input. I will need to set up a sort of mechanism. No, you know what? It's sending ASCII characters. It's not sending UTF-8 encoded characters. I think that makes a difference as well. Because ASCII characters would all be 1 byte per character, but UTF-8 can be variable length. Um, and if the ASCII characters are 1 byte each, we have a good, like, I don't remember what the size was. Hold on. I think I have to look at the MTU, the minimum or the maximum transmission unit size. Give me a second. Let me look up. Where's the tab, dude? Okay, there it is. Okay. UDP data max size, or, well, UDP MTU size. It says here the maximum MTU, so maximum transmission unit size of UDP can be unfragmented. We can receive unfragmented is 1460 bytes, so 1460 bytes. That's 1.5 KB worth of data. So, okay, yeah, you know what? Okay, one Twitch message, if I remember right, the limit is 500 characters, and that's a pretty big paragraph. Like, that's a fairly long message. So keeping that in mind, I don't think it's going to be like, if I'm typing it out, I don't think I'm going to be typing, longer than that. Yeah, yeah. I don't think I'm going to be typing longer than that. There's also, I feel like, in both of these different modes, both of these different input modes, the text input mode and the audio input mode, there's going to be different ways that the AI voice comes out. Because when I'm speaking like this, there's definitely, like, sometimes I speak, a bunch of sentences in one go, but quite often I have breaks in between. Sometimes I'll even, like, break up one of my like one of the sentences. Sometimes I'll have breaks in between a sentence as well. And then of course there's this repetition thing that I do where there's one sentence and I might say it two or three different ways. They all mean the same thing. So like yeah, my point is, oh, then there's this stuttering as well. So my point is, with audio input, it's going to be a little different than text input, and I feel like it's also going to be it's also going to be what's the word? What's the other word for like obvious? It's going to be obvious whether I'm typing out the message or if I'm saying it. Because if I'm saying it, then it's going to show up as such in the text. That would be interesting to find out, though. It would be interesting to see how, like, see what the differences are. Oh, also, this is one of those pieces of my tech that I'm gonna happily uh, open source, because this is not going to be connected to my VTuber app in any way. And I mean, even if it was connected to my VTuber app, like there are components of my VTuber app that I have open sourced. So I mean, I guess there's it doesn't make any sense saying what I said. Um, but yeah, this is one of those things that I'm going to be able to open source pretty happily. Um, I need to I need to see if I want to. Yeah, I need to see if I want to download the models, um, the models and their weights, or if I want to make it so like each time I run the app, it's downloading a new version of it. I don't know. I think it probably caches the model and the weights. I think so. I don't remember. I'm gonna have to look into it, because once I start doing like once I start using it, it's not going to be like a one-time use. It's not going to be a one-time. Um, the programs are not like one-shot programs. I'm going to be using them over and over again, right? So um, I don't want to have to download the models and their weights every single time. I mean, if the models and their weights are small, okay. But if the weights are massive, then I don't want to have to do that every single time. Not to mention, once I fine tune the model, I definitely need to save that somehow, right? I don't want to have to fine tune it every single time that I run the program. That doesn't make sense. So yeah, I'm gonna need to look into how to run models locally. Yeah, yeah. Okay. So during the last data science lab stream, I was going through this thing and I kind of got stuck on, well, not stuck, I was kind of like running experiments to understand exactly what was going on here. So we started running into this error, and it took me a bit to realize that the error was not with the linear method, it was with the flatten method. Because if you look at the definition of this neural network here, we have defined a flatten method, or well, not defined, but like we are holding a reference to the flatten method in our own created variable here. And in the forward method, which is the method that gets executed when the neural network is run, when the neural network is given some kind of input data, first the data is passed into flatten, so that that entire tensor can be flattened into a 1D array, and then that gets passed into the linear stack, which contains a bunch of methods for our neural network layers. So this was giving an error, and I initially thought that it was the linear method that was giving the error, but it turned out that it was the flatten method that was giving the error. and then I started looking into it more and doing running more tests and doing more experiments and stuff. And the last thing I remember looking into is the difference over here. So the difference in this case, would be if you look at these two. So we have a variable called I1, which holds this tensor, and I have two different lines showing two different shapes for the tensor. So in the first one, we have a 1 by 2, I guess you could say. Yeah. It has one row and two columns. Right. So this is 1 by 2 dimension matrix, or a 1 by 2 dimension tensor. Actually, wait, no. Hold up. That's wrong. That is wrong. No. My bad. This is a 2 by 1, not a 1 by 2. This is a 2 by 1 because it has two rows and each row has one column. And then this is a 1 by 2 because it has one row and that one row has two columns. So I was running tests to see how the flatten method behaves with each of these tensors. For the time being, let's get rid of these just so there's no confusions. Okay. Confusion. Just so there's no confusions. Whatever. Is this running? I don't think it's running. Oh, I think I need to restart. Okay, so let's run this first. And once this is done running, then we can move on to the other two code cells. So I've been trying to run, and I'm doing these experiments just so I get a better understanding of what shape of tensor it's expecting, because I find myself kind of getting confused about what shape of tensor I'm supposed to be passing into the linear layer. I mean, obviously, it depends on the linear layer's parameters as well, right? But given those parameters, what should the shape of your tensor be? Because depending on the linear layer's parameters, you're gonna have you're gonna have a different shape tensor for the weights, and so your your input tensor's shape has to be of a shape that can be multiplied with those weights, because if the multiplication is not possible, then it's going to give an error. So each time I find myself kind of confusing the two things. Well, not confusing the two things, but getting confused about what shape I'm supposed to be using. So I need to find a good way to kind of remember this, and I feel like the best way that I'm going to remember it is if I kind of make a post about this thing, explaining it myself. I found that that's a good way for me to remember it, at least once I understand it. Okay, this is taking some time. So I think what I'm going to do is refresh this page, and hopefully after that it should be fine, because earlier this did have like a warning kind of thing that, this thing has been running for like 12 hours. I haven't refreshed the page since then. Okay, it's almost... All right, so let's run this, and hopefully this time it should be quick. Oh, I think I should also look at... Oh, yeah, well, I was already looking into it. Give me a second. Okay. Um, all right, great. So the cell is done executing. Now we should be able to run our neural network definition, which is here. Give me a second. This other stream that I have running is a little loud. Let's turn that down. Oh, is this done? Is this done executing? Give me a second. All right, that's done. Great. All right. Yeah, we are good now. Okay, so in this case, we don't get an error, but in this case, we get an error. Let me scroll down. There's no error here. Where was I getting the error then? Because, okay, after you flatten this, oh, oh, it doesn't. Okay, hold on. Wait, yeah, this is what I was trying to understand. I don't think it was the fact that both of these were giving an error. Let me just, dude, I'm having trouble remembering it because I was doing some other stuff as well on the side. Yeah, okay, so there's no error being reported here. So I think both of the shapes were fine. Where S is the size at dimension I. Wait, where SI is the size at dimension I, and asterisk means any number of dimensions including none. I didn't get it. Wait, what? So any number of dimensions, but then it starts at the start dimension. Oh yeah, the start dimension. I forgot about that. So it doesn't care about it doesn't care about the first dimension. It starts from the second dimension. So what would that be in this case? And in this case, I feel like that would already... Hold up. So what does this return then? Like, wait. Okay. So it leaves the first dimension intact, and it goes for the second dimension. All right. Now, if we did this, it leaves the first dimension intact, which in each of these cases is, there's one in the second dimension, but like in the first dimension, it's still a row. So like if we are talking about this, the first one, let me create... Okay, so in the case of the first one, we have 2 by 1, right? So that would be 2 rows with one, what do you call it? Okay, so let's use zeros. So it would be 2 rows, and each row has one column in it. But the other one is a 1 by 2, meaning it has one row, but each row has but it has one row, but that one row has two columns in it. So it it operates on the second dimension. Yeah, it operates on the second dimension. Okay, so then from there, I guess the next thing is passing this into. Wait, it doesn't accept this. It accepts this, right? If I try to pass this into the linear layer, we should be getting. Okay. The error is mat1 and mat2 shapes cannot be multiplied. So this is a 2 by 1 multiplied by a 2 by 4. Okay. All right. Yeah, so it should be a 1 by 2 matrix. This is a 2 by 1, and after flattening, it remains a 2 by 1. But on the other hand, this one, this is, what do you call it? This is a 1 by 2, a 1 by 2 matrix. Yeah, okay. All right. Okay. This is a 1 by 2 matrix. I remember there was something else. This was a while back when I'd read up on like how the linear layer expects its data. I remember learning that it would be possible to pass in multidimensional, well, not, what am I trying to say? Not multidimensional, but like batches of data like at once into into the neural network, but I never actually got a chance to test that out. I wasn't sure how I should go about it because I wanted to test out if there would be a way to somehow, like, would that in some way be faster than passing in, the single batches, or the single sets of data? So like, would it be better to pass the entire batch of data at once, or pass in like individual pieces of data? I'm not sure if I'm doing a good job of explaining this. Let's say we're talking about a batch of images, right? A batch of grayscale images. Each image, because it's a grayscale image, let's say it's not RGB, it's just R. So it's just one pixel value, right? And let's say it's a 28 by 28 image. So you're gonna have that many. Oh, I think I just realized something else that I was uh kind of curious about, like in terms of flatten, like what exactly flatten does. I think with the images, because okay, let me show you this. Okay, so we can, oh wait, it's downloading. Okay, it's done downloading. Great. Now, we call next, and this is a tensor. Okay, let's print out this tensor. So this is the image. Actually, I think, wait, this is not one image. This is multiple images, I believe. Hold on. This is a tensor, right? Let's print out the shape. Yeah, it's multiple images. Now, if we look at what is it? 0 and 0. Yeah, that should be it. So we should have these values, right? And then this entire thing gets flattened into one. Okay, I get it. So we flatten this. Actually, maybe we should flatten this instead. Yeah, there it is. Wait, yeah, yeah, no, that makes sense. That makes sense. So we flatten this whole thing. What if we start by flattening here? Yeah, so this becomes the entire array. Yeah, okay, you know what? It doesn't, I guess it doesn't make a difference. Does it? Does it make a difference though? I feel like it would make a difference. Yeah, because like if we are, oh shit, I missed the ad timer. So there's going to be an ad starting in a couple of seconds. I guess I'll take my hydration break then. Okay, if we are talking about, so this is a tensor, right? Let's say we are trying to load the shape of this. There is no shape. Oh, that's interesting. Why is that happening? Hold up, hold up. Oh, there it is. Also, what was this? Is it like implicitly calling squeeze? So, wait, that's interesting, dude. Yeah, that's interesting. I didn't know it was doing that. But yeah. Um so if we take a look at the shape here and all right, there's the there's the ad timer. There's an ad playing right now, so I'm gonna take a hydration break and see you guys in like 30 seconds. Okay. All right. So, let's say no, okay, we need to run some tests here. Okay, let's say we are talking about this and we have what am I trying to go for here? Okay, yeah. Let's say we are doing this. Okay, we're not gonna pass it into the neural network yet. Okay, so the flatten operation doesn't seem to do anything here, right? What if I instead of this? Oh wait, no, we could just specify start dim here, right? Start dim equals 0. Okay, so if we start it at 0, then this is the result. It flattens the entire tensor, right? But by default, it is 1. We are not specifying that we want it to be flattened at the 0 dimension, so at the first dimension. We want it to be flattened from starting from the second dimension. Though I'm curious about why that is exactly. Like why is it being set up in this way? Oh, there's probably a reason for that. Yeah, yeah, there's probably a reason for where was it? Here. There's probably a reason for this specifically because often this is No, often each of these contains more than just this. It also contains the class. So let's test this out. Let's try printing a underscore label 0. So that comes out as a tensor. Okay, that is okay. Oh, wait, that's a tensor containing only one value. All right. Okay. Let's try, instead of this, let's say we did just a data equals next a. So now we have a tuple, right? And let's do a data 0 dot shape. If I remember right, this is a list. So if I did this, we would probably get an error because this is a list. Yeah, okay. So this is a list, but the first element, or well, each element in the list is a tensor. And let's take a look at the shape. All right, that is the shape. Let's take a look at the shape of each thing in there. Okay. And each of those things that's now it's not making sense, but like in my head it makes sense. Right. We No, you know what? I don't think. Okay, so here's what my thought process was initially, that maybe it's one over here because they're trying to provide a way for the class to be part of this as well. But I don't think the class is a part of this at all, because the class is like, fuck's sake, hold on. The class is its own separate thing. So like this list has two items in it. Yeah, this list has two items in it. One item is a tensor containing all of the images, and the other item is a tensor containing all of the classes corresponding to each image. So, yeah, that doesn't answer my question as to why we have one over here. Maybe it's some kind of organizational thing. Okay, anyways, I can maybe I'll find out later on as I start working with more data sets. Maybe it'll make more sense. Right. Why was I doing this? Okay. I forgot. Oh, hold on. Oh, I think it's making sense now that we are not passing in a start dimension of 0, because if you look at the example given here, where was it? Was it here? No, I think it was in the previous one or the one before that. Right. I think it's no, it wasn't this, but there was I think this did mention how we can pass the data in, right? Okay. So we can take this as an example, because here we have the training data. Okay. We access the training data. Wait, where's training data being defined? Iterating and visualizing the data set. Okay. Right, this is training data. Okay, cool. But this is still the data set. This is not the data loader. I'm looking for the data loader. Okay, once we have gotten this thing then we get the size, and then we have to squeeze this. We have to squeeze this to get rid of the one dimension, or that dimension containing one. Right? I don't remember if a squeeze operation was taking place elsewhere. So if, wait, there's, where exactly was it? Hold on. There was a thing somewhere here where it actually runs the model. So we've defined we've built the neural network here, but there was a thing where it defines the model. Was it this? Here they're explaining AutoGrad and how the whole system works. Okay, let's try the next thing. Okay, right. So we load the training data from the data set, and then we use the data loader to load the data from the data set. This is our neural network, and then here we create an instance of the neural network. Great, awesome. So far, I'm not seeing a squeeze operation taking place. Okay, now here we have the training loop, and in here, we're going to be passing in, okay, batch, enumerate, data loader. Okay, in here, we are unpacking this. This is probably the batch number, and this is the batch data, because this is unpacking that. Okay, cool. So we pass X into the data, or X into the model. X at this point, oh, there's no squeeze operation happening. Okay, okay, so there's no squeeze operation happening here, meaning it's going to skip that one, because, hold on, to explain what I'm talking about. Wait, let me make sure it's just passing in one. So it's enumerating, it's enumerating, it's iterating over this this entire wait, enumerate data loader, but doesn't data loader contain a batch of images as opposed to just one? Yeah, batch size is 64, and each linear layer only takes 28. Let me try running wait, give me a second. Let me look at this. Okay, training loop, data loader. Um, so so it's passing in the entire data loader, right? Each time. And that's our test loop. Okay, we can run the test loop later. First, we have the training loop. In the training loop, we pass in, for that many epochs, we each time we pass in training. Wait, what just? Oh shit! What did I click? Okay. All right. So we can leave test loop out of it for a second. Let's look at train loop. In train loop, we have train data loader. Train data loader is, give me a second. Train data loader is here, and this contains 64 batches. No, I don't think it contains 64 batches. It contains how many ever batches, but each batch is of size 64. Let me just confirm that by looking at my own code. Right, so here we have data loader. Data loader is an iterable, and we are able to call next on this to get the next one. How is this working exactly? Okay, let's try printing out the length. Since this is an iterable, we should be able to, I think. 938. Okay. 938 multiplied by 64, because we have a batch of 64. 60,030. Yeah, 60,032. And I'm guessing this would change with the size of the batch. So let's say I made the batch 200. Yeah, okay. This changes. That makes sense. Okay, cool. Right, so what was I trying to check again? I forgot. Oh, yeah. So we have our training data loader, which is an iterable, meaning we can call next on it, right? We don't call next though. We pass in the data loader directly in the training loop. Okay. And then we have the size of the, we are storing, oh, that's the size of the data set. Oh, I'm curious about this. Hold on. Yeah, let's get the size of the data set as well. Oh, this is the size of the entire data set, which is 60,000. So there are 60,000 images in this data set, and then that gets divided up into how many ever batches of 64. Okay. Okay, that must have sounded, I don't know what that sounded like on, I'm curious. Hold on. How loudly does the mic pick this up? Okay. Pretty loud, I guess. Okay, all right. Okay, what was I doing? Hold on. I need to not lose track of what I was doing. So we iterate over the entire data loader, right? But then we are passing in, dude, if the data loader is, how many batches are batch size 64. Okay. So there's going to be about 900 or so batches for this. Okay. So we have our data loader here. Let's try creating a for loop just to iterate over this. Okay, for batch and then x, y in enumerate ds01 loader. So from what I remember, the enumerate method, it gives you two, I don't remember the exact order, but looking at the variables that we are creating here, I'm just gonna take a guess. I usually confuse which one is on the left side and which is on the right side. But the enumerate method, it iterates over an iterable, and each time it gives you an index and the data. So that way you can make use of the index if it is required in some kind of like calculation or something. But on the other hand, if you just do the regular thing, let's say for I in ds01 loader, it just iterates over this directly, and it returns each of the, let me show you. It iterates over this iterable and it gives you each of the items. So you don't have an index. See this? Okay. So I guess this, uh yeah. Yeah, okay. So this prints out the entire batch Is this 64? I don't think this is 64. Is this 64? This might be 64. Okay, never mind. Okay, 1, 2, 3, 6, 9, 10. Yeah, it might be 64. Okay, yeah. So 64, and then there's like 900 more of those being printed out. All right, back to this. So here, if we print out batch, we get our index. If we print out X, we get our entire batch of 64. Wait, that's interesting. Where's the, oh yeah, it's Y is the class. Okay, what is the size of, or what is the shape of this? Oh God, it is, holy shit. This is still running. I probably shouldn't do that. It is still running. It is still printing. It is still printing. Give me a second. Let me cancel this. And let's also not delete this cell, but I need to clear the results. Clear cell output. There you go. Okay. Yeah. Let's print that out. All right, that's 900 of that as well. So let's cancel that. Okay, so what I'm trying to understand here is, oh, you know what I should do? Oh God, this is freezing. Let's do that. Much better. Holy shit. Are we good now? I made something that's running in the cloud freeze. Hold on, dude. No, you know what? I don't think, no. Actually, yeah, it might still be running because this button is not. Wait, is it some other cell that's running? Okay, dude, let me just refresh this page. I fucked up. While this is reloading, um so the reason I did this thing that caused that issue was because I was trying to figure out what exactly is going on here. And right now, it seems to me like they're passing in an entire batch of 64. Oh, sorry about that. It seems like we're passing in an entire batch of 64 images at once. But here's the interesting thing, and this is where we come back to that shape thing that I was talking about, because it was where was it? Here, I think. You see this? The input for the linear layer can have any number of dimensions before it. Any number of dimensions, including none, and this. That's kind of so when I read this initially, I was like, okay, so this means that we can probably pass in batches of data at once. So then the thing is, it's processing entire batches and not individual images, which is great, right? But like, I'm having trouble visualizing how that would be working. not doubting like whether it works or not. I'm just trying to visualize what that looks like in terms of training the neural network. Yeah, let's leave the page. Give me a second. Okay, so let that load again, and then I might need to retype that code because I don't know if it's saved or not. But yeah, okay. So I I've been trying to understand how, because okay, here's the thing, right? How this system is supposed to work is you give the neural network input, it processes that input, runs it through the various layers of the network, and then you get output, right? You compare the output to, or you compare the output that you got to the output that you actually expected. So you compare your predicted output to the expected output, and based on that, you are able to calculate your loss. And then you use the loss, and well, you don't, but AutoGrad uses the loss to create a gradient or to calculate a gradient, and then based on that gradient, it it changes the weights and biases accordingly. And you run this multiple times, and each time you change the weights and biases a little bit more based on what AutoGrad has calculated, in order to eventually get to the point of um, least error, I guess, in order to minimize loss, basically. The whole idea is that you're trying to minimize error, you're trying to minimize loss, and so you have to keep going through this iterative process. Now, I'm able to imagine what this looks like when there's one input being passed through, right? I'm having a hard time imagining how the weights are being affected when you're passing in entire batches of data in there. Like, is it that it's going through each one of them and wait, no. Yeah, no. I need to find a way to visualize this. I need to actually understand like what happens when you send an entire batch of data as opposed to like one piece of data. Okay, let's run this. Wait, is that done running? Okay. And then we run this as well. And then we don't run this because this is what caused a problem the last time. So we print out X and then break. I need to make sure to break this so that it doesn't continue printing. All right. So this, if we get the shape of this, this is one batch of 64 images, meaning in this example here, where was it? I think it was an optimization here. Meaning in this example here, we are passing in an entire batch of 64 images into the model, and then we are getting a loss based on that. This is the bit that confuses me. I guess I can read. Set the model in training mode for set the model to training mode. This is important for batch normalization and dropout layers. Unnecessary in this situation, but added for best practices. Oh, okay. So this gets used. Wait, dropout layers are. I think that gets introduced in what, convolutional neural networks? I think so. Okay. Uh, yeah, yeah. So I'm trying to understand this bit. Though, okay. So now that we have this question, maybe I can write this down somewhere so I remember it. Um, let's call this current doubt. How does it work when we pass in an entire batch of data? Example, uh, this shape versus one piece of data. Actually, I don't think I need to mention. Oh, yeah, okay. One piece of data. Example, 12828. So that's our current doubt. I need to make this a bit bigger because this text is a little too. Well, I don't need this to be a heading. I can make it smaller though. Yeah, that works. That doesn't. Let's make it that big. Okay. Oh, um, yeah, that works. So that's our current doubt. That's what I'm currently trying to understand. Uh, in terms of how these things. I forgot what I was saying. That's what I'm currently trying to understand. What else? There was something else that I was trying to understand, right? How Flatten handles these uh these tensors. I think I got that already because like Flatten. So okay, I think there's a difference between the flatten method and the flatten layer. So let's do I1.flatten and see what this gives us. Yeah, yep. There's definitely a difference because this flatten starts at 0. So it starts at the first dimension, whereas the other flatten, it starts at 1. So if I did this, we get that result. It starts at the second dimension. Okay, what was I saying? Oh shit, I've been streaming for an hour. Holy shit. Time kind of flew when I got busy with this. Okay, okay. Carrying on. Um right. So the flatten did I call it the flatten layer earlier? I don't think it's a layer, but like flatten from NN, it from the NN namespace, it starts at dimension 1 or dim 1, whereas the flatten method starts at dim 0. All right, so now that we have that cleared up, um, let's try this again. Okay, all right. I think one of the reasons, hold on just a second. There it is. I think I understand now why um okay, so let's say print f shape before flatten, and then here we can do i1.shape. Shape before flatten was 1 and 2 and 3. Okay, let's do yeah, let's do that. So it'll be 1, 2, 4. So that's our shape before flattening. And then after flattening, maybe I can add some more text here. Uh, Give me a second. Yeah, we can get rid of this. Right. So I think I understand why we have that one thing, right? I think it's so that you can flatten it much more easily. I think yeah, I think that's it. Though, I mean, is there really a need for that? No, I don't think that's the only reason. I think that there might be some other reason there as well. Um, yeah, I'm trying to think of reasons why we would have um, the thing in this. Hold on, 64, so and so, 28, 28. I'm trying to imagine why we would have the thing in this shape as opposed to. Actually, I could just copy this, right? As opposed to this shape, but I'm sure there's other stuff as well, because I mean this might not be the only reason why you would need to add an extra dimension in there. Oh, wait, no, no, that still doesn't make sense. Because back up. If we did this instead, so let's say I got rid of this. Hold on. Okay, maybe it has something to do with the way that the network processes the data. Because okay, let's say we are talking about this, right? So we have 1, and then we have these. We are not using the flatten method. We are using the flatten, this. And could it be because of the way that, um, no, dude, that doesn't make sense. Wait, let's try something here. So we have, where is it? Where is it? This. So we have this thing, right? This is an entire batch of, how do I specify flatten start dim? Okay. Flatten start dim equals 1. Okay. And then we'll print that out. That does not flatten it. Let's try printing out the shape. Okay, right. If, on the other hand, we did it this way, actually, I think that did flatten it. Hold on. Did that flatten it? I'm not sure. No, I don't think it flattened it. Let's try and get the shape of this. It says 64.7. Oh, it did flatten it. Yeah. Okay. The entire thing. Yeah. Okay. I'm trying to imagine, like, in what scenario would it be helpful to add this extra dimension in there? And I'm wondering if it's the way that I'm not. Hold on. Hold on. Okay. Let's try this. So if we start flattening at the other dimension, well, okay, so then one benefit that I'm seeing here of flattening at at dim 1 is that we entirely get rid of dim 1, and 2 and 3, and we just flatten all of it into a 1D array. You know what? I could try asking R1 or DeepSeek. I could try asking DeepSeek. Give me a second. Okay, labs.perplexity.ai. Okay, all right. I'm using the fashion MNIST dataset provided with PyTorch to learn how to build and train FCNNs. Something that I noticed when using the data loader class to chunk up the data into batches of 64 is that each batch had a shape of 64, 1, 28, 28. What I'm wondering is, why is there how do I ask this question? Why is dim 1 even necessary? Why is the shape 64, 1, 28, 28 and not 64, 28, 28? See, something that I like uh, about DeepSeek, and I feel like DeepSeek was kind of my introduction to reasoning models, which is sort of a new thing. Uh, Something I really like about it is that it it gives you an answer, but prior to that, it also does a whole bunch of thinking, and it shows you its thinking process. So you get to learn quite a bit even throughout that thinking process. Now, it's also worth mentioning that people aren't always looking for that. So depending on, whether you want to read a bunch of extra things or not, you can decide whether you want to use the reasoning model or you want to use any other version of a model. Oh God, this is so much text. Okay, all right. So this is what I was talking about. Like, if you want to read the reasoning, then yeah. Okay, let's try to figure out why the batch shape in PyTorch's data loader for fashion MNIST is so and so instead of so and so. So the user is asking why there's an extra dimension with size 1. I like that it understood that. Why there's an extra dimension with size 1 in the second position. First, I remember that images in computer vision are often represented with channels. For example, RGB images have 3 channels, so their shape is height, width, and so and so. But fashion MNIST is grayscale. I was about to say that, and fortunately, like it remembers that. Fashion MNIST is grayscale, which only has 1 channel. So maybe PyTorch includes the channel dimension, even if it's 1, to maintain consistency. To maintain consistency with how other image datasets are structured. That way, whether it's grayscale or color, the data. Give me a second. Sorry. Nose problems. Okay. But Fashion MNIST is grayscale, which only has 1 channel. So maybe PyTorch includes the channel dimension, even if it's 1, to maintain consistency with how other image datasets are structured. That way, whether it's grayscale or color, the data has a channel's dimension, which makes processing easier since the model can expect a consistent input shape. I also recall that in PyTorch, convolutional layers expect the input to have a channel dimension. For instance, conv2D layers in PyTorch require the input to be in the shape batch size, channels, height, and width. Oh, wait, so I just understood what this means. So the 1 mentions how many channels are there, and then we have the height and width. Okay. Wait, so in the case of how would that work in the case of an RGB image? Because in the case of an RGB image, the last dimension, it should be 3. Actually, no. In the case of an RGB image, the last dimension is gonna have its own list containing items of 3, containing batches of 3. So if there's only 1 channel, like in grayscale images, you still need to have that dimension. If the data loader didn't include the channel dimension, then when you pass the batch to the model, it would throw an error because it expects the channels to be present. Let me check an example. Suppose we have a batch of 64 images, each of size 28 by 28. Without the channel dimension, the shape would be so and so, but a conv2D layer expects the input to have so and so. Okay, so PyTorch's datasets probably include the singleton dimension to comply with the expectations of the convolutional layers. Additionally, when using transforms in PyTorch, like converting images to tensors, the two tensor transform automatically adds a channel dimension. For example, a PIL image in grayscale is converted to a tensor of the shape 1 height width. So when the data loader batches them together, each sample already has a channel dimension leading to the batch shape so and so. Another angle is that in PyTorch, the convolution, the convention of, give me a second. In PyTorch, the convention for image tensors is NCHW. Number of batches. Oh, that's a convention. Okay. So number of batches, number of channels, height, width. This is different from some other frameworks that use NHWC form. Oh, okay, it's just switched around. Okay. By maintaining the channel dimension, even if it's one, PyTorch ensures consistency across different types of input data and layers. Wait, but what if the user is using a fully connected network instead of a convolutional one? The question mentions FCNNs. In that case, the input would typically be flattened into a vector. For example, each so-and-so image would become that. Okay, yep. Uh, but even then, when you load the data, the original shape includes the channel. So you might have to manually reshape it by squeezing the channel dimension or flattening it. So the reason the data loader gives so and so is because the dataset is structured with a channel dimension, even if it's one, to be compatible with PyTorch's expected input formats for for layers like conv2D. Okay. Even if the user is using an FCNN, they would need to handle the input shape by either squeezing the channel dimension or flattening, including the channel, which would be so and so. But why doesn't PyTorch automatically squeeze that dimension? Probably because it's easier to keep the channel dimension explicit. If you have to mix, if you have a mix of grayscale and color images in different datasets, keeping the channel dimension consistent avoids confusion. Also, also some operations might require the channel dimension to be present, and having it as one for flexibility in case the number of channels changes. Example, if you later use a dataset with 3 channels, you don't have to adjust the code structure as much. Okay. So in summary, the dim one is necessary because PyTorch's processing pipeline expects a channel dimension, even if it's only one channel. This maintains consistency with other image data types and ensures compatibility with layers that require the channel dimension. All right, cool. Great. So that answered the question. I don't think I need to read the other stuff. Um, that's interesting to find out. That's interesting to know. And I guess, yeah, once I get to convolutional neural networks, we're going to find out that, yeah, this is useful. Okay, so here's what I'm going to do. Okay, I'm going to end the talking stream here, and I'll start up a mute stream after some time. Give me a second. Yeah, no, I'm going to start up a mute stream in some time anyways. So I'll end the talking stream here, and I'll start up a mute stream in a little bit. So I hope you guys have a nice day, and I'll see you all next time, being probably in an hour or something. Peace.